Hi, my name's Deborah Fowler, and I'm going to talk about RBD for Layout. So let's start by creating a tube. I'm going to dive inside and put on end caps, and then I'm going to shrink this down to maybe a little bit shorter. I'm going to grab that information here, copy parameter, paste relative reference, and then divide by 2 so it's sitting on the crown plane, and multiply by 0.5, your choice. And I'm going to increase the resolution. I'm going to create a poly extrude. Now you can do this from the shelf tool, polygon tools, and up there. I tend to work in the network view. That's just my style, my choice. In here, I'm just going to inset the 0th face, and maybe that's a little too much. Let's just make it a little thinner. And then I'm going to grab that particular face that it's created, which is going to be group 51. If you want to check that, you can always just turn on the faces. Looks like it's actually group 101. But I did another inset. Let's not do that. And let's just take a look at our faces. Yes, 51. Okay, so 51 we are going to push down. Now it doesn't have to be all the way down because we want to fill this, but just make it look like it's filled, so we can always have a false bottom. We're going to fill this with objects. Okay, so there's our container. We're done with that. What we're going to do next is create another GeoNode. I'm going to call this my object. And there's two ways we could do it. We could create two separate objects and have points and objects to copy on those points and use an RBD instance object. Or we could just simply go ahead and do the copy to points node and make that an RBD object. That's the method I'm going to use today. So in here, I'm going to create a object. Let's do a box. And that box we're going to take and we're going to raise up a little bit because we're going to drop things from that into our object. We're going to make this a little smaller because we want it to be about a little bit smaller than that bowl because we're going to be dropping into that bowl. Okay, and we don't have to raise it too high. We're not trying to do a simulation that we're viewing, so we're just going to do this for layout. So where we put it, as long as the objects have time to move, we're fine. Again, I'm going to make this a little bigger, maybe a little bit higher, and we're good to go. There's two things I could do. I could either create it into an ISO offset surface and scatter points into that volume, or I could do points from volume, which does it for me. I'm going to use that. So points from volume right here. And what that does is it takes the surface, creates it into a volume, and scatters points inside. Now, I could use point jitter. I don't really need to do that for this setup, so I'm going to skip that. If you change the separation, you'll get less and more depending on what you're doing, so I'm going to revert that to default. Okay, so now what I'm going to do is a copy to points. And before I forget, I'm going to grab that copy to points and turn on pack because we want pack geometry going into the RBD. And then I'm going to grab a sphere. And that sphere is going to be a little big, so I'm going to scale it down and then take a look. Okay, so now we have our spheres that we are going to make into an RBD object. Right now there's no simulation. Let's go ahead and, without anything selected, if we hit RBD object, it says select objects for RBD objects, press enter to accept. I'm going to select that and hit enter. And now we have a dot network. So my dot network contains inside objects, solvers, forces. So our object is going to be referencing the object to dops, which we're going to look at in a minute. My solver is the bullet solver, and the force is acting on gravity. Okay. So if you watch this, it just falls down, right? It doesn't have any knowledge of that tube yet because we haven't made it a collision object. Let's go ahead and go to the collision tab and create a static object. Okay, now if we look in our dot, we can see that we have an object that is your tube, that is your collision. So if we play this now, we see that it lands on top of the tube and it falls all over the place. The problem is with the bullet solver, in order for it to be faster, it assumes everything's a convex hull. Easy solution is to go in here and change our collision instead of, and I'm just going to go to the first frame so you can see what it looks like. This is what it looks like now, right? So if I turn off the geometry display, you can see that that's our approximation of our object. We need to change this to concave so that it has a hole. So now you can see it has a hole. We're going to turn off that so it's not chewing up cycles, turn on our proxy geometry in our dot network and hit play. And now you can see that they all sink into the bowl quite nicely. Now there's one little one that escapes. And that's okay. I'm going to show you a technique to get rid of that without having to rerun your sim for any reason. Okay, so for that little guy, we're going to take care of that. Run your sim until you like the layout, and then you're good to go. Now, I'm just going to show you what you would do with that little guy so we can see it in view. Let's go back over here. So we've got our dot network, which is our calculator. We've got our object in here. You can see what it's done is it's added to our copy to points, it's added a rest node, and it's added a name attribute so that it can distinguish those as individuals, and then it's referenced a null node that is being used, or labeled a null node that is being used in the dots. This is bringing the information back. So each time step it calculates, where am I, until you stop the simulation, or until the objects settle, in our case, because we're doing this for layout. So we're settled at around, let's play it a little further. They're pretty much settled at frame 100, let's say. So I'm going to go to frame 100 just so I can see it. And that looks pretty good. Now, I'm actually going to back up a little just so you can see that little guy going forward, because even if we're at frame 100, he's still round. We don't want extra geometry. We don't want that factoring in. So if I hit space G, you can see that he's way down there. We don't really want that. So what I'm going to do is show you the setup that I can use to get rid of that. Okay, so in here, go a little further till we see that little row guy right there. I'll show you what I'm going to do is I'm going to put down a delete node. And then in here, I'm going to grab this and use, instead of enable here, I'm going to go to bounding volumes, click on bounding box. I'm going to shrink that box a bit, and let's make it a little bit bigger in here, but shorter in Y. Move it up a bit, and yeah, good. Okay, you might think, hey, what's happening with this? Let's make it a little bigger again. What I'm doing is I'm deleting things, but I want to delete on points, and I want to delete non-selected. So what that does is it keeps everything in the bounding box, but gets rid of everything else. So if I bypass that, you can see that that little rogue one is there. That way, anything outside of my object is going to be deleted, even if it goes tumbling off. Okay, so now we have a clean little setup, and what we want to do next is cache this. So we said at frame 100 we were happy with the layout. What we're going to do is bring down Filecache node. And in the Filecache node, what we can do is we can set this up to make this easy for us. We're going to change this to explicit. I like to use explicit. This one I'm going to change. I'm going to call it, for right now, I'll call it points. Now we can either leave that $F in there or not. If we do, we want to make sure that we reference the file. So what we're going to do is we're going to save that file as a single frame, say save to disk. So now you can see that this little icon appears and it's loading from disk. So there's no simulation going on in here. So there's the points. But as soon as we move this, there's no simulation going on, but it's only frame 100. So what we really need to do is grab that frame and just use that. Okay, so now we're referencing that frame for anything in here. So now we have our cached out geo. And in fact, if I go up here and reset my simulation, you can see that no simulation is going on. Awesome. So we have that set up. What do you do with it? Well, you could create a whole bunch of geometry with it by just doing a, for example, copy to points. So let's do copy to points, and let's create this and make a grid. So now we have a grid, and let's grab that grid and copy a whole bunch of these over. Let's do a scatter, and the scatter will automatically get rid of my normal information that is making it topsy-turvy. So let's not do 1,000, let's do 100. And now we have maybe 10, actually, just for the purposes of demo. Let's take my grid and shrink that down so that I have my objects. Okay, so I now have my objects, but one of the problems is I don't necessarily have my containers doing the same thing. So what I want to do is make those points available to my containers. I could also have object merged the container in, but I'm going to throw down a null node and use _outPoint so that I can easily find it when I go to do object merge. And then now I have my same points available over here, so I can go into my container. And this is still going to act as my collision. But over here, I grab a copy to points and I render this part. I'm going to grab with an object merge the points coming in. So we don't want to go to the tube, we want to go to the object and go to the output points. And in there now I have those objects acting in the same way, and let's be efficient and pack them. Okay, so now we have our setup, which we're happy with. But let's say now we want to set up our camera. Okay, so let's do a new cam, and suppose that we only wanted to show maybe that much of the scene. Okay, so let's zoom in a bit more. There we go. Well, now if you look at that, we've got all of this stuff laid out that's not being seen. So there's a really good technique to use, especially when you're doing like particle systems or something that's really heavy. You want to get rid of things that aren't seen in the camera view. That's called culling to camera. And let's just, I'm noticing an intersection there, so I'm going to go into my object, and let's just take that grid and make that a little bit farther out. You can see that it's working for both because, of course, it's referencing the same point information. Okay, so there's our setup. Now what we want to do is get rid of the ones that are outside my camera view. So if I zoom out, there's a whole bunch of ones that we're not actually seeing. So in here we dive, and let's set up a volume. And that volume, and you could do this with either VDBs or volume. I'm just going to use a volume node for now. And then I'm going to set a density attribute up at the top, and I'm going to set this to, say, 0.5. And then from camera, I'm going to grab my camera, and that camera is now being defined as a volume. Okay, so there's my camera. I need to set my near plane to be closer to the camera and my far plane to be farther away so that I have a nice camera fructrum. I can also estimate it a little more accurately, but that gives me a nice camera fructrum that I can define as a volume that can see what is in, what is out. Well, how can we take advantage of that? With a group node. So add a group node, and what that does is it gives us the ability to take, and again, we're going to click off that, click on this, a bounding box for volume. So points or vertices only. So we're going to set that on and use points. And then we're going to take our points that we're using and grab that and feed that into both places. I'm just going to move that over there. So that now what we're doing is we're grouping our points that are within that camera fructrum. Now I need to turn on invert here and turn this on to the same value that I'm using for my estimation. So you can see it's selecting these points. Then what we want to do is do a blast node. Could be blast or delete. I'm going to add that in there. And again, I'm going to just tidy up my network a little bit here. Now we don't want to blast everything. What we want to blast in here are just the things that we're not seeing. So delete by selected group 1. Okay, so that leaves in the camera view the ones that we're seeing. But wait, you say, there's some others that we've missed. Well, all we need to do in this case is we need to go into our camera settings and extend out the fructrum. So if we want to get a little more of Y and a little more of X, we just manipulate these values until we start seeing the missing pieces. So in this case, let's see what we're missing here. We're missing in Y, so let's decrease this a little more. There we go. Okay, so probably about 0.5. Yeah. All right, we're pretty tight into this camera. 55. There we go. Okay, so now let's go ahead and check that we've got still everything. There's one more in there, which would be our X value. So let's extend this one a little bit more and see if that took care of it. Yes, okay. And I always try to make it as minimal as possible in terms of the fructrum, so I don't want it to be too big right there, maybe 0.25. Okay, and again, you could, whoop, got to go a little farther. I'm going to use the ladder controls. There, okay. So now I have a value that essentially allows me to have blast on where I'm just getting rid of things that are outside my camera fructrum. Excuse me. So if you pull out, you'll see that if we weren't using blast, there'd be 2 more containers of things. Now, it might not seem significant in this particular setting, but when you're using, for example, a simulation where you're using pop grains or something that's really heavy, it can be hugely significant for your cache sizes and also for your render times. So we've now set this up so that we have geometry. But if you look at this, in general, we start seeing the Where's Waldo. So we start seeing things that are very much the same. So what we want to do, we can see that pair, that triple. So that's what I call the Where's Waldo. What we want to do is change our orientation, and that's an easy thing to do. So I'm going to add a attribute randomize. And I'm going to put that up here before we get into the group. And you can see it's changing the color. That's not what we want. We want to change the normal. And all I need to do to get the normal back to being calculated correctly for my copy to points is 0 the Y component in here. Okay, so now I'm back to having variation, but let's make the variation a little more pronounced. And so now it's randomly selecting, so we don't do the Where's Waldo as much. So we've got a random variation on our object so that we can have a little bit more interest in our visual. So if we look at our camera, we can see that they don't look all identical. We can see that one right there is kind of like this. We can manipulate this, see if we can get a different configuration that we like better. Yeah, that's better. Okay, so it gives us a little bit more variety. Okay, good. So that is a really quick way of setting up a nice, efficient, and clean setup. But there's one other thing I could have done to clean this up. And if you look at this, there's a lot of information we're carrying around. So best practices, just like using null nodes with capitalization to easily find them, best practice is to delete attributes. So let's do an attribute delete and get rid of everything we don't need. So in this case, essentially, once we're done the simulation, we really don't need most of the attributes. So we've got a lot here. All we really need is position. If we were doing a simulation and actually rendering the simulation, we'd want velocity and so on. But right now, all we really need is orient and position. So let's go ahead and say delete everything, but not the point, which it won't let you delete. But I do it for completeness, and not orient. And that way, I now have deleted those attributes, but I need to recache. So I left this number in here so I'd know which frame. So I'm going to go back to 100. And in this case, because I'm loading from disk, it's still loading from disk. So I'm going to simulate this. So essentially, you can see that it's simulating to that frame now, because I turned the simulation back on. I could have saved to disk, and it would have done the same thing, because I've got simulation on, but just so you can see it. And then I'll save that to disk. So now it's saved again, and I have again, orient and point as my attribute. So that reduces the size of your cache, which can also save you both memory footprint and also reading it in smaller files to deal with. So good all around, best practice. Okay, so now we have a clean, efficient system. What about rendering? So that's next. Okay, so rendering. Let's just take a single version of this for the moment. And let's go ahead and render it in 3 ways. Redshift, Mantra, and Karma. Okay, so let's start with Redshift. So I'm going to create a material node, first of all. And I'm going to create an attribute randomize. Okay, there it is. I'm going to plug that in over here just so we can view this in a single instance. And while I'm at it, I'm going to get rid of this tube and center on my object so we can see it. And let's just do new camera, and we'll do cam 2. Okay, so now we've got our object, and we've got colors on it. But if we render this in Redshift, we're not going to get anything, even if we put a material on there. But we can get something if we put the proper material settings. So let's create an RBD material, or sorry, an RS material. RS material builder, and go in here. I'm going to get rid of this. I'm going to do RS material, because I like the drop downs that are free. And let's change this to plastic. I'm going to do an RS point attribute, which will bring in the point information for color. I'm going to plug that into diffuse color. So if we don't do that, we won't get any color. All right, so now let's go back into our object, dive inside, and we're already randomizing the color. Let's go ahead and put that shader on. And now we have a Redshift shader. Let's put a dome light just so we have some light in here. And I don't really like the fact that the dome light always gives me a background, so I'm going to get rid of that background. Okay, so now we have a dome light. I haven't even added an HDRI or anything like that yet. I just want some light in there. Let's go ahead and render this. So Redshift render view, and we're going to do Cam 2 because we haven't set up that yet. So in here, we can see now we have our multiple colors. So let's see what would have happened if we went into our material and not had this. Yeah, exactly. So this is what we want. We want to be able to assign that color to each of those individual pieces. Okay, so that's Redshift. Let's try Mantra. So we'll get rid of Redshift and let's go back to Mantra. So Mantra is relatively easy to do as well. We don't want to use IPR of Mantra or Redshift, so let's go into the output node, get rid of these. And what we're going to do is render create Mantra PBR. That has the correct settings for us. We're going to reduce the size because Mantra takes a little bit of time to render. So we're going to make sure we're not rendering at huge resolution. Best practices, again. And let's move this down here to our camera and lights. Now what we want to do is go in here and create a reference to a Mantra shader, not to a VOPNet Redshift. So here we can just go principal shader. And in this case, what we're going to want to do is use pack color. And I, by default, usually set this to 1 in case I want to add a texture or something like that. Also, depending on what your checkboxes are, sometimes it acts as a multiplier. So in here, what I want to do is go back to my object and assign that as principal shader. And then let's see what we have on the top level. We've got this. I'm going to get rid of that because we want to use a regular Mantra light. So in here we can go into our lights and let's do sky and sun or just an environment light. Either one's fine. Okay, so I now got to have an equivalent of the Redshift dome light. Okay, so now we have a setup for Mantra. Let's go ahead and render it. There we go. Okay, we're not on the camera. Let's go ahead and change that to Cam 2 because, again, it defaults to Cam 1. And wait for it. This is why we're excited about GPU, because CPU is a little longer to render. And there it is. Okay, so this, in this case, the principal shader, by just clicking this use pack color, see it goes away. Use pack color, it comes back. Okay, so we're good to go. So that is an example of creating the color in this particular object. Now, I used attribute randomize, which set this up to point. If you see failures in this, you can sometimes change this by doing an attribute promote to make it a primitive. That works too. Okay, so right now this is working. We're all happy. Now, let's do it in Karma. Okay, so in this case, we're going to use Karma with the exact same shader because Karma actually does respect, even though we're supposed to be using a shader that is for Material X, Karma will respect Principal Shader to a certain extent. So we're going to get rid of this render view for now, and what we're going to do is go back to the scene view. We're going to grab a LOPNet. Here we have our LOP network. And inside this LOP network, we're going to grab a import. So scene import all. And that brings in our entire scene. And you can see right now we're actually rendering in Karma in the scene view, which is super sweet. Okay, one thing that I didn't cover was what about if you wanted to sim more efficiently with a proxy? So let's go ahead and do that. We've got our DOP set up. Let's go in here. And we already file cached this out to frame 100. And we receive back our geometry. We're going to change that a little. We're going to go back to our DOP network here. And let's just re-sim this. So I'm going to go back to the beginning since the orange indicates there's something's changed. I'm going to go back here and sim this to a different frame, maybe frame 30. Okay, so there's a simulation. Just so we have something that we can distinguish. And then let's go ahead and grab our delete, which we want to do. And then our attribute delete, we have to be a little careful. So right now we're going to go back up here. You can see here we've got information in here that we've deleted everything but point and orient. We want to be careful now because what we're going to do is go into the DOP network. And instead of fetching geometry, we're going to create points. So instead of fetching all of that information, it just gives you the name, orient, point, pivot, scale, velocity, and angular velocity. So we still want to delete this, but we don't want to get rid of everything because we're actually going to use some of those. So we still need some of these. Now we don't actually need angular velocity or velocity in here, but we do need pivot and scale. So possibly scale. In our case, probably not, but let's go ahead and do that. We can either do that or skip doing the attribute delete at this point because there aren't that many extraneous attributes, but let's go ahead and continue. So I'll do scale and pivot. Okay, so now we have those saved, and we're going to go into our save to disk, and you can see now we've got frame 30. Probably should have saved that at frame 30 rather than 100, so let's just go ahead and do that again. Okay, so now we have frame 30, and you can see that if we were doing fetch geometry, and we use this, we can see that that is what it looks like, but instead what we're doing is we're just doing the actual points. Okay, so now we're good. We've got it cached. We're good to go. All right, so let's do transform pieces. Okay, so I'm going to do transform pieces and required template points. Sometimes you'll need rest points. We'll see if we need them this time. We're going to grab our points, and then I'm going to create this. I'm going to grab this, and I'm going to put the same thing on here as I did before, but right now we're doing it after the fact, so after the simulation. So you can see there, we've got transform pieces, and as soon as we do that, we're good to go. We've got points in here with orient, point, pivot, and scale, and in here we've got our transform pieces, and we've just plopped this on. So we could replace this with, for example, something like rubber toy. Let me scale this down. And whatever geometry. So the idea isn't that you would have a bunch of rubber toys. The idea is that you would have another sphere that was, let's do match size. There we go. So we would have another object that we were using instead of the generic object. So in here, we're just transforming those pieces to those particular things, but really, our object should match whatever our proxy is. In this case, it's just our sphere. But that allows you to bring in something that is more heavily meshed or whatever it might be. So if we're looking at these, let's say we did something to this, it also allows me to manipulate materials after the fact, change in various different things. So just wanted to point that out. Transform pieces is cheaper, easier, and a better way to sim. Okay, thank you for watching.